Hi, this is Subramaniam Shankaran. This is the next eighth video in the series towards Google Secure AI framework. This attack is called model reverse engineering. So, these reverse engineering attacks are not new to artificial intelligence or not new to security. In fact, in cryptography, we have an attack called adaptive chosen plain text attack and plain text attack, adaptive chosen ciphertext attack, and chosen ciphertext attacks. So the attacker will have an access to the plain text and the algorithm, okay, and the ciphertext, and not the key in line with the Kirchhoff's principle. So we need to the attacker needs to find out what the key is. Okay, he will use various tactics to find out what the key is. Okay, that's the reverse engineering method. Same thing is applicable for AI also. Okay, so that's only the model reverse engineering. Attacker does not have an actual access to the model, but he's trying various other techniques to find out how the model actually works. Okay, so he can have it as a shadow AI, okay, or try to find the vulnerabilities in the model, etc. Okay, so we'll see what are the different techniques to do on model reverse engineering. Okay, Coca-Cola analogy. Now, the highly praised secret, or one of the highly prized secret in the world, is Coca-Cola's recipe. Okay. Now, having said that, okay, even in India, okay, there had been a lot of cases where people produced a fake Coke. Okay, then they were questioned on unhygienic conditions producing the Coke, etc. And it was a different case altogether. In fact, in my CSSP classes, I always say the one of the world's highly priced secret is the Coca-Cola's recipe. No, in a way, when I'm actually saying it, okay, the other side, somebody is producing it without knowing the actual recipe. They are just matching the taste. Okay, it's like an hash value collision attack, right? I don't know what the input to the hashing algorithm is. But if the hash value is same, okay, for two different inputs or whatsoever it is called as a collision attack. Okay, I was able to match the hash values. A lot of techniques are there. Okay, in the similar concept. In this particular case, the Coca-Cola's analogy, without knowing the recipe of the Coke, I'm able to find out, get the taste. Okay. Similarly, for a model, I'll keep on querying. I keep on querying the model with 10,000, 50,000 questions. Look out for that particular response, okay, and I can use those responses for and to make it to do a training phase of another model, okay. So this will become exactly like what the production model is, okay. Now they will form this the recipe and fabricate this Coke, and instead of Coca-Cola, they'll say Coca-Cola, Coca-Cola, okay. And for the similar way, when I was delivering a training in Bangladesh, I asked the person, so where do you work? He said Citibank. I thought the CITI bank, okay, but it's CITY bank, okay. A lot says the typo squatting. It might or might not be a typo squatting, okay. So copycat chatbots, big companies releases a powerful, okay, the paid AI model. The attacker queries 50,000 questions, okay, get the responses. This 50,000 questions and the responses become the data set for the training, okay, training, testing, and validation for the duplicate or clone AI, okay. Stealing the confidence, okay. Let's say in a loan approval application, okay, the customer is going to new customer is going to upload his details and and the application is going to say yes or no. Okay, there's something called as a confidence score. Now the application, you know what, I'll tweak here and there on the income, okay, and the pin code, etc. Try to find out when does it say yes and when does it say no. Okay. Now this is also a data that I will have, okay, as a data set for training the new model. Okay. Now model inversion, recreating the faces. Assume that there's an AI related or AI based facial recognition application, and it's for the multi-factor authentication based on, let's say, the physiological biometrics. Now, I don't have access to, okay, I have access to the model, but I don't have access to the employees, okay? So what I'll actually do is to query the model, okay, showing a face. Okay, sometimes the model responds, oh, this face belongs to Ram, this face belongs to Rahim, this face belongs to Peter, okay. So, and I'm using a lot of images to query. Okay, sometimes it responds saying that, yeah, this picture belongs to this particular person. I can find out whether the data set contains the image of that particular person and his membership also. Okay, the reverse engineering, even that is another attack. Okay, the membership inference attack is also possible. Why is dangerous? Okay, intellectual property. Now, and model is like an application that is developed by a company, is a proprietary property. So if this particular if I can do a model inversion, okay, and create my own model, okay, which is a clone model that is going to be an against the licensing, okay, or against the trademark or copyright, whatever it is, okay. It is an intellectual property right, okay. It's a breach of an IPR. So there's very dangerous security vulnerabilities. If I can have a model, okay, clone, and if I find the vulnerabilities on the model that is cloned, I know the original model will also have these vulnerabilities. So it's easy for me to attack the actual model. Privacy leaks. Okay, the example I told you about showing a photo, and the model responds saying, "Okay, yeah, this picture belongs to John or Peter or Ram, Rahim, etc." Okay, so that's a privacy leak. Now, how can you actually prevent it? Okay, now there's something as a rate limiting. This rate limiting is also not a very new concept with artificial intelligence. We had this as a clipping level or threshold, okay, in the IT security. Now, if a normal user is going to query 50 or 100 times a day, if going to say 50,000 queries a day, obviously there is an abnormality, okay, or anomaly detection. Okay, so I can keep and fix and rate limit saying that, okay, the number of queries should be 50 or 100, not more than that. Okay, so if this is the case, then you can stop 50,000 queries and getting the answers to form a data set to have a clone AI model. Okay, so this is one way of doing it. Otherwise, output modification. Okay, now this is like an auditee and auditor, okay, scenario. Okay, usually what happens is when the auditor is going to question us, we don't tell him the complete answer. Okay, we will be very specific, and sometimes it is not quantifiable. Okay, because more you tell the auditor, more he is going to question you. If it's going to be a qualified auditor, and the auditor is also smart. So sometimes what happens is the auditor is just an auditor. Okay, that means that he would have graduated somewhere. Okay, the big people come and they take the project. But when they actually send the auditor for questioning or doing the auditing, they'll send the college graduates, etc., which is a norm with big consulting firms or big auditing or certification bodies, etc. So what happens is if the auditee is smart enough, even if it's going to reveal extra information, the auditor cannot catch. Okay. Now what we actually say is do not reveal complete information. Let the output be like a qualitative representation of risk. Okay. In the qualitative representation, it's going to be very high, medium, low, and very low. Okay, it's not going to have a numerical figures. So if you want to represent it this way, okay, it is tough to get the exact quantitative figure from the model. Okay, so this is one of the defenses. Otherwise, watermarking. Okay, say there is AI generated content, or you can say that this content is generated by this particular company, and it could be Google, OpenAI, whatever it is. Okay, it need not be visible for the human eye. Okay, so if the picture is used somewhere else, okay, the company which has generated that, okay, there's a beautiful video, okay, with Google watermarking on the YouTube. I'll send you the link as well. Now, if they can be in particular watermarking, okay, which is not visible to the human eye, okay, but that can then figure out, okay, whether this is generated by the original company or somebody copied it. Okay, it is like steganography. Okay, steganography is also a concept in cybersecurity where you are hiding some information in the picture. Okay, so if it's AI generated and if you want to have watermark, you can hide the information of the picture. If the picture is copied, okay, so you can say that, okay, this picture is copied from me because there's a watermark, secret watermark in the picture. Okay, so that's also a best way of defense. Anomaly detection. Okay, usually what happens is we can guess, right, when people come to do something. Usually, normal people go to the market, they choose the item, they put it on their basket, they come to the billing, okay, they finish it off. But if there is suspicious movement, okay, the guy going to the corner and looking at something, there are suspicious movements, okay. Similarly, for an AI application, if it's a normal query or abnormal query, okay, you can detect the way, okay, the queries have been put in. Okay, this way also you can detect an anomaly. To detect an anomaly, you need to have a clear, okay, the prompts that have been used, okay, and what could be the differentiator. Okay, so this anomaly detection is also possible by which you can have a defense. Again, the reverse engineering. So these are the trainings that we actually have. Certified Chief AI Security Officer, which is our flagship. AI governance and AI risk is our flagship. Data protection. Now you need to have a data protection officer who can understand AI. Okay, the governments are saying cloud first, AI first. So the traditional data protection officers who just understands the common data protection terms, etc., is not going to hold good. AI is a different ball game. It's an evolution. Okay, it's an evolution. You need to keep up with the evolution, otherwise you'll be left behind. Okay, because it learns. It's not just a programming. It learns from what's happening. So you need to understand all that to become the best of the data protection officers. So AI risk officer, ISO 42001 lead implementer auditor with a lot of case studies. Okay, and in fact, most of this trainings comes with and complementary implementation kit. You can write to us on training at ieee.org.uk if you wish to join for any of these courses.